Hi, everybody. It's Miss Boyce and Miss Dow. We hope you had a nice weekend. We are moving on right now. We're going to chapter 9. And we're going to start with radicals and like square roots and simplifying square roots. Okay, so let's start with the do now. If you have your blank notes in front of you or you're just going along with the answer key, let's take a look at the do now. Okay, so what we're asking you to do is say, all right, what are each of these squared? So each of the numbers squared. You can probably run through them pretty quickly, so we can do that. You can do it with me, or you can move along, right? So we have 4, 3 squared is 9, 4 squared is 16, because remember, what does squared really mean? What squared really means is the number times itself, right? So if we're doing 7 squared, it's 7 times 7, so we know that that's 49. Okay, so let's finish these up. Okay. And I'll tell you why we're doing these. We need to know the answers that we're getting is the numbers are the numbers that we need to know. Okay. So we're getting 144. We're getting 13 squared is 169. We have 14 squared is 196. And then 15 squared is 225. So what each of these numbers are called, right? All these numbers, all the answers that we just got, right? Those are called perfect squares. And those are the numbers that we're going to need to know. Okay, so let's move on. So like I said, we're doing properties of radicals. So it says find the square root of each number. So what we just did, we kind of did, now we're doing the opposite. So now we're saying, okay, what times what is 144? The square root of 144 is, the answer is just a plain 12. That is your answer, is 12. And that's because if I took 12 squared, right? If I did, okay, the opposite of a square root is a squared. So 12 squared is 144. But again, our answer is just 12. The square root of 144 is 12. And 144, that means it's called a perfect square because it's a nice number, what we call a nice number, right? The square root of 225, if you go back to that do now, it was 15. Okay, so the square root of 225 is 15. And this is a funny one because it's a variable, but we can still do it because, again, this x squared is actually a perfect square simply because it has that little square there. So the square root and the squared actually cancel each other out. So your answer is just x, okay? And that, if you want to look back, that's kind of how we got these problems, because I can rewrite this. I can rewrite the square root of 225 as the square root of 15, right, squared. But again, the square root and the squared cancel each other out. So what are you left with? That's why we're getting 15. 144 can be simplified as the square root of 12 squared. Again, inverse operations, the square root and the squared cancel each other out. So that's why we get 12. And those are ones that we need to know. They're called the perfect squares, and we'll list them also on our papers in just a bit. All right, so why don't we move on? Okay. So sometimes they are not going to be perfect squares, and that's where we have to simplify. And so let's move on to an example, and I'll show you. So let's do this first. At the top of your pages, what I want you to do is I want you to actually write perfect squares, and we're going to make a list, right? So our first one is 1 times 1, 1. 2 times 2 is 4. 3 times 3 is 9, and so on and so forth. 4 times 4 is 16, 25, 36. I think we're going to go to 144. Is that right? Let's try it. So 49, 64, 81, 100. Our next one would be 121, 144. I don't think I give you any bigger than that right now. So do you see what I did? These are all perfect squares. So what we're going to do with these is we're going to take these numbers and see what divides in to the number under the perfect square. So let me do the first one with you. So you want to try to go with the biggest perfect square. Okay, so I know I'm going anywhere below 100, right? And we know that 100 doesn't divide into 108. All right, I'm going to keep going down, Maybe I would try 49. So let's take a look. You can do 108 divided by 49. Does it divide into it evenly? 49. No, okay, so that's not our perfect square that we want. All right, let's go to 36. Let's just try it. 108 divided by 36. And oh, look, it does divide nicely. So watch how I do this. So that means I use the square root of 36 and I multiply that, right? What did I multiply that by to get to 108? Or what it was 108 divided by the square root, or the 36? It was 3. So I keep those in the square root because that means the square root of 36 times the square root of 3 is the square root of 108. So again, I'm kind of working backwards. I'm breaking it up. All right, well, now we know what is the square root of 36. You got it. The square root of 36 is a plain old 6. And then what's left over? The square root of 3. So if you don't have a perfect square under the square root originally, these are what your answers are going to look like. They're going to be a nice number, and then they're going to be a square root. All right, let's try another one. So take a look at 80. Okay, so out of these perfect squares, what divides into 80? And this one can be a little bit tricky because our first thought could be, oh, maybe 4 does. And yes, let's take a look. 80 divided by 4 is 20. Absolutely, it works. However, we're trying to get the biggest perfect square. So if 4 works, well, then my thought would be, okay, well, let's look at 16. Does 16 work? So 80 divided by 16. And again, what we're looking for is no decimal. And look at that, we don't get a decimal. So 16 is the higher number that divides into 80. So we're going to use 16 as our perfect square, right? So we're going to say, okay, 80 divides into the square root of 16 times, and when we divided it, what did we get? And we're going to put that under the next square root. So 16 times 5 gets you back to 80. And again, what do we do from here? We take the square root of 16. What is the square root of 16? And if you're having trouble with this, take your calculator and you get, my square root button on here? Ooh, where is it? Oh, somewhere, I don't know. Oh, sorry, I thought it was on here. Okay, well, it will be on your calculators. So if you take the square, let me see for a second. Oh, there it is. Okay, so let me do 16, and then I have to put second into my calculator, and there it is right there, square root. And again, look at what I get. And some of you may know that. But again, if you're having trouble, use your calculator, okay? So the square root of 16 is 4, and what's left over? We don't do anything with that square root of 5. So your final answer, a simplified version of square root of 80 is 4 times the square root of 5. All right, let's try 242. And that's where this list really comes in handy. So I can start with my bigger numbers, right? Well, why don't I start with 144? So 242. So 242 divided by 144. Let's see if that works. Do I get a decimal? Yep, I get a decimal, so that doesn't work. Okay, let's go to the next one. 242 divided by, now I'm going to try 121. Let's see, does it work? Perfect, it does. So again, I'm going to split that 242 up into the square root of 121 times the square root of 2. Because 121 times 2 gets you back to 242. What is the square root of 121? Okay, so this is again knowing our times tables. The square root of 121, in case you don't know it, square root is 11. Okay, so I have 11, that one square root of 121 becomes 11, and I'm left over with the square root of 2. So that is your final answer. And then let's look at that last one. Again, 32, your first thought could be 4, but again, if you try 4, then you should automatically try 16. And let's take a look. Oh, excuse me. What is, oh, no, hold on. What is 32 divided by 16? Does it go into it evenly? Yes, it does. So let's use 16 because that's our bigger perfect square, our biggest perfect square that divides into 32. So the square root of 16 times the square root of 2. What do I get? What is the square root of 16? That's one that you will know. 4, plain old 4 times root 2. And that's your final answer. Okay, let's go to the tries. Why don't you pause it for a second? Why don't you give it a try and then come back to me? Welcome back. What we should have gotten was the square root of 4 times the square root of 6, which would become 2 root 6. Okay. Your next one, number 2, you should have gotten the square root of 25. I'm going to try and do these. So, no, I'm not. We're going to do the square root of 25 times the square, times the square root of 3. Is 25 times 3. Get you back to 75. And the square root of 25 is 5. And you're left with root 3. So 5 root 3 you should have gotten for number 2. Number 3, the biggest perfect square that divides into 98 is 49. I hope you got that, guy, right? 98 divided by 49 is 2. And so what you should have gotten there was 49 and 2, so it was 7 root 2 is your final answer. Because the square root of 49 is 7, and then you're left over with root 2. Over here, 4 is the biggest perfect square that goes into 8, and the square root of 4 is 2, and you're left with root 2 inside the square root. So that was 2 root 2. Okay, let's move on. So there's different things like with multiplication, division, that we can do with square roots, okay? So let's take a look at this one. Sometimes it's easier to simplify first, and sometimes it's easier to simplify after. It just depends, and the more we do with it, the better you'll get with that. So take a look at this one. If I do the square root of 2 times the square root of 8, what do I get? Well, if I do 2 times 8, I get 16. So that's the square root of 16. And the square root of 16, that 16 is a perfect square. So the square root of 16 is simply 4. So that was easier to multiply those together. Let's take a look over here. You see this 3? Well, that has to hang out for a little bit. There's an invisible 1 if there is nothing in front of the radical, so that's just an invisible 1. So what you can do is you can do, okay, well, what is 3 times 1? That's 3. Let's let that hang out over there. Now let's do the square root of 5 times the square root of 5. And I get the square root of 25. And again, that's a perfect square. So remember, I still have that 3 hanging out here. And now I multiply by, well, what's the square root of 25? 5. So what is 3 times 5? There's multiplication in between these. So it's going to be 3 times 5, and 3 times 5 is 15. And so your final answer is 15, okay? Take a look at the next one. So you have this 12 hanging out, and then there would be a 1 in front of here. So 12 times your invisible 1 that we can put there would be 12. And again, that's kind of hanging out until further notice. And then again, even though they're not the same, the square root of 3 and the square root of 2 are not the same, you're still allowed to multiply those because they're both in the square root. So 3 times 2, I get the 12. I get 12 hanging out over here. And then I get the square root of 6. Can I simplify the square root of 6? Is there any perfect square that divides into 6? And there is not. So this is your final answer. Let's take a look at the next one. So now, look, I have a number outside and I have another number outside. It's not an invisible 1. It's actually 4 times 3, which is 12. And then let's multiply the 18 times 4. There's 2 different ways to do this. I'm going to actually multiply the square roots together. So let's do 18 times 4. And I get 72. Okay, so that's the square root of 72, remember. Well, now what I have to do is I have to simplify that square root of 72, just like we did on the previous page. I'm going to pick the biggest perfect square that divides into 72. Again, let this 12 hang out over here. I'm going to simplify the 72 by using the square root of 36. That's your biggest perfect square that divides into 72 times 2. Okay, what is the square root of 36? Well, we know it's 6, right? We know I'm multiplying that by this 12 that's been hanging out over here. And we know that I have this square root of 2 left over. So now I have 12 times 76, which is 72. And what's left over is root 2. Again, there were different ways to start that problem. That's one of the ways I could do. I could have started out by saying, well, I know that 3 root 4, I know the square root of 4 is a perfect square. So I could have done 3 times a regular 2 right away, which would have been 6, which then times 4 would have been 24, and then simplified 18. So again, there's different ways to do it, and all ways are okay, as long as we get our most simplified answer, okay? And then remember that 36 was the biggest perfect square that divided into 72. So let's try these tries, pause it again, try them, and then come back to me. Okay, welcome back. Let's multiply our root 10 times root 10. Our 6 is being multiplied by our invisible 1. So we have our 6 times 1, or 1 times 6 is 6. And then we have our root 10 times root 10 is the square root of 100. But I know the square root of 100, don't I? That I do. That perfect square is 6 hanging out there times 10. And 6 times 10, we know, is 60 is what you should have gotten there. Okay? Take a look at the next one. 7 times 1, that invisible 1 is 7. Square root of 5 times the square root of 6 is the square root of 30. And although it's a bigger number, there is nothing that divides into that. That's a perfect square. So your final answer is 7 root 30. Good job. And let's keep moving. That last little bit. What I just want to show you here for division, so that was all multiplication that we were just dealing with. So when you have the square root of 3 over 4, all that means is you can simplify, you can separate the numerator and denominator as long as you keep the square root over both. Okay, so this becomes the square root of 3 over the square root of 4. And why do we do that? Well, now I can do the square root of 4, right? Because that's a perfect square. Square root of 3, nothing's happening with. We keep that as the square root of 3 over the square root of 4, which we know is a plain old 2. Your final answer there would be root 3 over 2. Let's take a look at some examples. So again, what I just showed you, same thing here. I'm going to, because it's division, you can simplify inside first, which I can't here. So that means what I'm going to do is I'm going to actually separate the square root of 15. That looks like a 13, so I'll erase that guy. Square root of 15 divided by the square root of 64, right? And the square root of 64 is, we know it's a perfect square, is 8, right? So we can get rid of that square root on the bottom, put 8. And there is nothing that divides into 15. That's a perfect square. So we're just going to say square root of 15 over plain old 8. Okay, that's our final answer there. Let's take a look at this one. Look at what happens if I separate these guys. Square root of 16, right, divided by the square root of 25. Well, this one's a nice one because they're both perfect squares, right? So I can simplify both of these. I can simplify the square root of 16 to be 4, and I can simplify the square root of 25 to be 5 with no radicals around them, with no square roots around them. That's my final answer. Those are my 2 examples there. And why don't you give it a try? Pause it one more time. Let's give it a try and then come back to me. Welcome back again for the last little bit. This guy becomes square root of 17 over 10 is what you should have gotten, plain old 10. And the next one should be this, nope, not square root. The square root of 4 is 2, and the square root of 49 is 7. And that's your final answer. Okay, good job, guys. Make sure you watch, refer back to these notes if you need to, and fill out the Google form. Okay, have a great day. Thanks.